in English. Good morning, everyone. My name is Catherine Chiluisa. I am the Dean of the Faculty of Electrical and Computer Engineering. We are waiting just like 2 minutes or so to start this presentation. Okay, let's start. It is a real pleasure to present you Dr. Carmen Vacao, who is going to present a research titled Using Instagram Posts to Characterize Urban Point of Interest, a spatio-temporal analysis. Carmen, the floor is yours.
Good morning, everyone. Thanks for being here. Today we will talk about a study we performed using Instagram posts to characterize urban points of interest. We conducted a spatio-temporal analysis in order to observe how a pattern can emerge even in the geography of the city or in the temporal behavior. So why we did conduct this analysis? Because especially in developing countries, there are very few digital data about people visiting points of interest in cities. As you know, when we have the local authorities who are governing the city, they need to know data about where people are to being concentrated, and not only that, but also at what time of the day, in which day of the week. However, in developing countries, the problem is we have very much a few sensors than those that may be available in developed countries. So the number of people visiting a point of interest, a POI, is estimated. It's just estimated based on intuition. So maybe sometimes you may have the capacity of a point of interest, and whenever you see it's full, then you know how many people are there in that moment. But it's a matter of intuition. We don't have data, and also we don't have data across time so that we can compare. For example, if whenever there is for example, a new policy, which is the impact of the policy. Also, well, there have been tons of studies in which authors show evidence that human behavior follow patterns in time. We are very predictable for some kind of activities. So we also wanted to infer those patterns in Guayaquil. Why in Guayaquil? For some reasons, as you will see, our study doesn't have any special features so that it cannot be replicated in different cities. It's very general, the data collection, etc. But also because, as I said before, these problems are especially important in developing countries. And Guayaquil is a very big city. It attracts visitors, and we would like to have some pattern, some way of characterizing those visits. As I said before, our main source of data will be Instagram posts. Sometimes we may think that in Ecuador people don't use a lot. There is not a great penetration in social media sites. However, it's not the case. There are many people in our population using these kind of platforms. So in Instagram, as in many other social networks, we have a ton of metadata. It is we not only have the post. No, in Instagram, most of the posts are pictures. We not only have the post, but we also have information about who posted this and which other posts this user published. We know also a temporal mark, and this is very important since one of the problems we were mentioning before is that we don't have data, and if we know by intuition more or less how many people may be in a place, then it becomes very difficult to know at what time of the day the people is there. I may know that people are visiting Malecon 2000, for example, in Guayaquil, but I don't know what time. So this temporal mark, even though in here you may observe just day, month, and year, however, when you get the post, you can also get the time at which this post was published. Well, and then we may have user comments, we may have likes. As I said before, there are tons of metadata when we work with social media information. We didn't explore, for example, the popularity of the post, and it can be explored in future work. Also, we may explore the relationships between the users so that you can learn if some user likes a place, maybe his friends also will like those places. Okay, so we went to take the city, search for the points of interest in the city, analyze those places using spatio-temporal analysis, and then we also went to develop some measurement of diversity in the city. There are many urban studies in which you learn that cities with more diversity are cities that attract more people. The diversity may come from different different, it can be constructed in different ways. For example, you have more diversity when you have more immigrants. When you have people coming from different places, you have more diversity. But also you have more diversity when you have attractions in different categories. If you have a city in which you build parks, amusement parks, and malls, very attractive malls, etc., then your city starts to be more diverse. This diversity, we want to calculate it at the level of the neighborhood, which is a problem. I said before that we don't have information about the city, and if we have a lot of digital information about the city, we have even less information about the neighborhoods in the city. So in order to do this, we analyze this Instagram geolocated post. In Ecuador, we face, well, in many developing countries, we face another problem. You may have a social media post, but those posts many times are not geolocated. In previous studies we have conducted, for example, sometimes we have observed around 1% of geolocated posts. In Instagram, even though the platform won't give us the exact geolocation, still the platform will give us the name of the place, and this name of the place, as we will see in the next slides, we can convert it to a latitude, longitude, to a geolocation. And then we propose a pipeline, a flow of steps to characterize these points of interest in Guayaquil. Okay, so where does our dataset come from? In Instagram, you have the post. You also have the user timeline, but there is functionality, which is the locations in a city. Basically, these are places in a given city. So we go there, we go to the locations in Guayaquil, and then we obtain a list of points of interest, which are listed in Instagram. For each of these places, we now go to observe the related post of those places. Then, once I have a post, let's say I have one given post by one given user, now I go to the user. And in the user, we get the user timeline. So this user timeline will guide us through other places this person is visiting. In this way, even though we start with a list of places, at the end, what we have is a set of users. So for those users, we collect the places those users have visited in a given amount of time. So following this procedure, we end up with more than 1.9K users and more than 38K posts. As I said before, you have a post, and for this post, maybe some of you recognize this post. This is located in Guayarte. So in Guayarte, when you have the post in Instagram, you may have just the text. You may have just Guayarte here. we need to perform a geographical analysis, a geographical aggregation more than an analysis. We need to perform a geographical aggregation. So we would like to have geolocated points. What we do is we take the name of the place, in this case, Guayarte, and using a Python library, we are able to obtain two important characteristics. The latitude, longitude of the place, it means the geolocation of the place, and an important thing for some of the categorization we will present later is the category of the place. This library has the ability to return to you the category. Let's say the place is commercial, is a hotel, a restaurant, is an attraction. So following this pipeline, we at the end we have 2.4K places, unique places, and these are the places that we analyze for Guayaquil. So the first thing is just getting the number of visitors per each neighborhood. We want to aggregate how many people are in a given neighborhood. For this, we take hold of an additional data set of the divisions in Guayaquil. This is the city of Guayaquil, and there is available and some administrative divisions by the municipality. However, those divisions have some very areas that are very large, and we wanted to have a more granular division. For this, we have our group, one member of our group have drawn the neighborhoods in Guayaquil following information from Google Maps. So using these divisions that we already have, we're able to aggregate the post in each of those. For this, we need some considerations. No? We need, for example, to know that we will take unique post by a user given a time and a place. For example, let's say that at 10:10, a user published 5 photos in a place. We shouldn't count this as 5 visits. We should count just 1. So at the same time, we get 1 post by 1 user, and it will be counted as a visit to the place. That visit to the place will be aggregated to the neighborhood. So at the end, what we have is the number of visits per neighborhood. So the first result that we can obtain is that we can rank the neighborhoods by the percentage of visitors they obtain. So we normalize the number of visitors in the neighborhood, but the total number of visits that we have in the dataset. And we have, this is the top 5 neighborhoods in Guayaquil. All of these have important attractions for people. There is a mix here. We have neighborhoods in which you have a well-established area with bars and restaurants. You also have this walk by the river, which is called Malecón 2000 in Guayaquil, is the main attraction. It's one of the main attractions in the city. So probably when visitors come, they for sure visit Malecón dos Mil. Then there is this neighborhood, Kennedy Norte, when we have malls. And it's, well, in a previous study, we observed how much people in Guayaquil visit malls during the weekends. And finally, there is this neighborhood which maybe some of us may think that it's not that visited, Bella Vista. But in this neighborhood, we have a place from which you can observe the entire city. And we also have some stadiums. So we believe that this is the reason why it is on the top 5. Well, as I said before, we not only want to have the number of visitors in a place, we also want to calculate some metric related to the diversity. As I said, the diversity, we need context for the diversity, and we need to define how are we going to consider that a place is more diverse. So what we decided was, if you have a neighborhood and the neighborhood has attractions in different categories, let's say that that place is more diverse if it is able to attract people more or less distributed among those categories. So for that, we use this concept of entropy, in which we have the probability that we will calculate this metric for every neighborhood. In this equation, I is the neighborhood. You have the neighborhood I, and J is the category J. So this is a probability that a visitor in neighborhood I chooses to visit a place in category J. So using this metric, we can calculate a diversity number for each of the neighborhoods. And we just, we aim to observe whether this diversity has any relationship with the number of visitors. So we have here the number of visitors per neighborhood. And in the y-axis, we have this metric, the category diversity metric. There is a correlation of 0.55. It's true that it's not a perfect line, because not all the neighborhoods are attracting people just because of the diversity, but there is a trend. There is a certain trend that at least there is some correlation among the diversity in a place and the number of visitors visiting that place. Next, we have already observed the diversity, and now we can analyze the temporal patterns in the visitor behavior. As I said, the human activity in many papers have been characterized, and the human activity can be very predictable if you don't have a disruptive event. So here we have the different categories we have analyzed in the study: attractions, fast food, commercial, hotel, restaurant. And we use a kernel density estimator to produce this distribution across the days of the week. So here you have Monday, Tuesday, etc., and Sunday, and the hours of the day. So in this band, you have the morning hours. In this but in the upper, you have the night hours. And this, we also, for the temporal distribution, we also divide the dates so that we extracted from the dataset, we filter from the dataset the dates corresponding to holidays. We took those apart, and we just got those the other dates. So, for example, in fast food, we observe that people are consuming fast food or are visiting fast food places at night during the week. And then during the weekend, Saturday, maybe in the morning, they grab something and nothing else. And it's interesting to see the shift from the fast food consumption to the consumption in restaurants. If you see, the fast food consumption goes in the first days of the week, while when you are approaching the weekend, the behavior goes towards restaurants. And these blue marks are for weekends. And you can observe that restaurants, for example, Saturday night, they have a good affluence. People are going there probably for having dinners with friends, for having dinner with family. Also, for example, for commercial, as I said before in previous study, we have observed already that malls are heavily visited on weekends in Guayaquil. Here you may observe that people may stay in malls until late at night during weekends. Well, we were asking ourselves, and we can probably extend the study to do the comparison, whether we would observe this in Quito. Probably then this behavior won't go until too late in the night, because in there are many places closing earlier. Well, as I said, we divided the information between the holidays and the non-holidays days, and we will compare just for three of the categories. We will do the comparison. So in fast food, this is the normal days, and these are the holidays days for fast food. So as you may observe, when a holiday is approaching, people probably leave the city, so they are not consuming fast food in those days. But when they come back from the holiday, probably to grab something to start before starting the new week. So we have some visitors on Sunday night. Of course, during will be higher, and people probably during holidays will start arriving earlier than they do during normal days. And finally, for restaurants instead, we had previously observed that fast food, people will grab some fast food when they come back from the holiday. But for a restaurant, probably what we observe here is that people who remains in the city they go restaurant on probably for lunch on Saturday. So if they decided to stay, then they are that day, no. But when they go from the holiday, they won't look for a restaurant probably. Okay, so our study, whenever you see in population, immediately you think in the how representative is the sample you're taking. And of course, if you go to a social media place, you are taking information about population, people with smartphones and people who have access to the platform, who are probably younger than the average population in the cities currently. In the future, maybe it will change, but by now there is some bias maybe towards young people. And in this study, we don't have it, but in previous studies, when we have taken samples from Twitter, which is also a social media platform, we have been able to correlate information calculated from the number of posts in the platform with information published by INEC, for example, obtaining very good correlations. The population is still you have and then an additional limitation is that you have private profiles where for which you cannot obtain the timeline of the user. Okay, so the team, Isabel Atiencia, Carolina Zambrano, Eduardo Cruz, who worked towards collecting the data. Maybe you put more attention on the analysis, but taking in the data had some challenges that we had to overcome for obtaining these 7 months of data during 2019. Now we have some directions. For example, we would like to see how this behavior have changed now that we have this disruptive event of COVID. Okay, thank you. If you have any question, I am here.
Thank you, Carmen. I mean, you can make any questions via chat, or you can also open your mic and make some questions to Carmen. Thank you very much, Carmen.
Hi, Carmen. This is Christian Silva.
Christian Silva has raised the hand.
Thank you. It was a really good presentation. Congratulations. I really liked it. I have a question regarding this big data issue or this big data project that you conducted. Basically, what I work in is in simulation of dynamic systems. And basically, the simulation of these dynamic systems is more, I would say, focused in assessing the performance of a structure to natural disasters, for example, an earthquake. Okay, that's basically what I do. One of the interesting things that I learned in one of the presentations in my research group was this study that one of my one of my colleagues did. He used Twitter data in order to assess the level of destruction or the level of damage, that basically an earthquake made in a particular area, in a particular zone. Okay, and this got me very interested, and I would like to explore this a little bit further. So would you be willing to discuss some sort of collaboration in this? Because it's very related. What you do, you're doing temporal analysis, but basically what you're doing, what we're using is, big data to establish some sort of behavior or some sort of result, right? So would you be willing to explore something like this, for further collaborations? Thank you very much.
Okay, I apologize. Just today, my internet connection is not helping. So, Christian, I was saying that for sure we are very interested in doing collaboration. We are working with different areas in which multidisciplinary teams will produce better work. I can, for example, we can arrange a meeting and I can explain you, we have conducted studies using this big data. We have conducted studies, for example, for predicting damaged areas in an earthquake. Then we
that was
also,
exactly my question. That's what I asked you. Exactly
yes,
that, yeah.
yes. We also have conducted studies to see how the behavior changes, looking at transactions in retails after a disaster. Okay. Then for geographical information, we conducted a study in migration. And for that one, for example, we were able to collect information for a good amount of time. And then we had very good results in estimating INEC variables. So for sure, we can have a chat.
Okay. Did you say that you conducted some studies using Twitter, right? Are you limited to certain types of social media? Do you think some social media are better than others, or do you have any preferences in this regard? Or
well, in social media, the studies we conduct are using Twitter and Instagram. Okay. Why? Because of the public nature of the platform. Okay. When you publish something in Twitter, you want to reach the whole population. Okay. There are very few private accounts. It doesn't happen, for example, in Facebook. In Facebook, everything is private by default. Okay. Unless you want to make it public, but then you don't have individual users. Usually you have organizations when you have this kind of public accounts. So this is why we work with Twitter and Instagram. When I started doing this kind of analysis here in Ecuador at the beginning, I thought that maybe the penetration was too low to be able to get any important inference. However, across years, we have been able to observe the contrary, that you can get very good approximations using these platforms.
Okay, I will definitely contact you. So thank you very much. It was very, very, very interesting.
Okay, I have a question about, I don't know if you can hear me. I have a question about diversity. Could you, beyond the formula, of course, could you expand a little bit about your explanation about what exactly you mean by diversity in your research?
Yes. Well, I cannot share screen now, but well, if someone can help with sharing screen, it would be nice to put the thing. Okay, so if you observed the formula that we, okay, now I can share. Thank you. Okay, if you observe the formula, what we're calculating here is an entropy. So we can observe. I wanted to annotate, but it seems I cannot. Okay, so in this entropy, we may think in a vector of categories. You have this vector of categories, and you may have all the visits concentrated in one element of the vector. So everyone is going just to one type of places. For example, let's say that you have a neighborhood. The neighborhood have the vector of categories, but when you calculate the numbers in the vector, you see that most of the population who visit that neighborhood goes just to the commercial category. And the remaining categories have very low numbers. If you have that distribution, your entropy will be low because it's concentrated just in one type of category. However, when people is starting visiting different types of categories in the same neighborhood, then you will have these values spread across the vector, and your entropy will start to go higher. So what we are defining here as diversity is a neighborhood is more diverse when it's able to attract people in different for places in different categories, because it means first that in that neighborhood you have different types of POIs. For example, you may have a neighborhood in which you have built a mall, but you don't have anything else, just a mall. But if you build neighborhoods with different types of attractions, then what we are defining here is it will be more diverse. And then what we want to look for is whether a more diverse neighborhood, as we have defined it, is able to attract more people, which is something that would interest to people in tourism, for example.
Okay, thank you very much, Carmen.
Thank
it
you.
was really clear. I encourage you to make more questions to Carmen, or maybe if you can do it in Spanish, it's okay as well. Pueden hacer también las preguntas en español. Gracias.
Gracias, Catherine.
Okay. There's a question there, Carmen, please. Two questions.
Okay, sí. Okay, Piero, do you think the approach will scale and be engineered into a multi-social network and multi-city tourism performance analysis tool? Definitely, because I've seen this already in place in cities in Europe. For example, in the Netherlands, they have pipelines in which they get all kind of information from, as you said, multi-social network platforms. And they use this as a feedback for tourism. But not only for that, they also use it in cities for safety. The challenge here is that you need the infrastructure to be able to capture information. The vast amount of information, the larger the information, the better, that you can get from the city. As I said before, especially in big cities in Ecuador, people are posting things in social networks. So when we finished the work of migration some years ago, I got more confidence that this data, if you collect it well, can be representative. because we were able to approximate very well some inexact numbers. Okay, so then Freddy Gonzalez has also a question. How can help to deal with this COVID problem and help local authorities to face this puzzle in a better way? Well, one advantage of social networks is that they give you dynamic information, and it's information that you are not requesting from the user. You are not you don't have to convince the user to use an app to report where is in this moment. So Instagram became very much a part of the user activities, of the user behavior. They are always taking pictures and publishing. There have been many studies, for example, analyzing food consumption behavior using this kind of information. So since you have dynamic information and you can collect this information very granular in time, and you don't need an app because people already have the apps in the phones, then you could observe places where people are concentrating. You won't be able to observe places. If you observe here the map, for example, we have some areas as Spatio-temporal, Las Orquídeas, where we didn't get any posts following the pipeline that we already have shown. However, for many areas in the city, you can follow the traces of people, and you can see at what time of the day there are more people concentration, and you also may know in which neighborhood it is happening. Again, as Piero was asking before, what you need is infrastructure. What you need is not a very expensive infrastructure. You need a couple of good computers which are collecting this information the entire day, so that you can replicate this time of analysis. And of course, you can add a lot more of analysis here. Okay, thank you, Piero and Freddy, for your questions.
There is just one, this last one question from Ivan Moran.
Ivan.
It is. How was the process to obtain Instagram information? Did you use bots? What difficulties did you have?
Well, Ivan, is a very good question, because Instagram has many, have very few API endpoints. So we used the endpoints whenever we could, but then we needed to automate the process. When we automate the process to collect the post, we set good sleep periods, so that we won't go against the platform terms of service. We try to be polite and replicate what a human would do when navigating the platform. But you are right. There are difficulties collecting this information, because contrary to Twitter, Instagram doesn't have that many endpoints in the API. And then Angeli Oyola wants to know whether we use specific hashtags. And as I said in the collection process, we didn't use hashtags. This is an approach, a very popular approach. Use hashtags when you collect information from Twitter or Instagram. However, what we use for the locations. we started by the locations because we wanted to characterize the points of interest in the city. So we started by the locations given by Instagram, and then we started going to the user timelines to see whether users have visited some other places that might be from interest. Okay.
Okay, thank you. With this, we are closing this presentation, this CHARLA FIEC. I want to thank again to Carmen and her team, Carolina, Isabel, and Eduardo. Thank you very much for your effort in doing research in such an interesting area. And again, Carmen, my congratulations to you. And thank you very much for all the people that have attended to this presentation. We were around 53 people, which is a lot. Thank you very much, and have a nice day.
Thank you. A nice day for everyone. Bye-bye. Bye, Catherine.